Okay, we're going to be working on some rules for differentiation. So I'd like you to look at the warm-up and scroll down on your notes and try the warm-up, pause your video and try the warm-up and check them when you're finished. Okay, so here are the solutions for the warm-up. You can check over those. So when you evaluate, and when x is equal to 2, so we get 3/2 for the first one. We have 1 over 32x for b, and so that's going to be 1 over 32 times 2. So that's going to be 1 over 64 for this one. Okay, just going through it, you have simplify the expression, so we simply complete the multiplication. And then where we solve, we have x is equal to 2/3 and x is equal to 4. So in this section, we're going to be finding the derivatives using the constant rule, power rule, constant multiple rule, and the sum and different rules. And we're going to use derivatives to answer questions about real life situations. So with the constant rule, the derivative of a constant is always going to be equal to 0. Picture that if you have a graph, y is equal to 4, and with the derivative, you know already we're talking about slope. So if you consider this graph of y is equal to 4, you know, where you might have a 0.45, and then you have another 0.417, who cares what it is, right? Well, you see the slope is 0 on that graph. So it makes sense that the derivative of the constant is 0. So we could say then if we find the derivative of each function, we have for a we have y is equal to 7, then we have dy dx is equal to 0. If we have f of x is equal to 0, then we have, just using the notation, f prime of x is equal to 0. If we have y is equal to 2, we might say that y prime is equal to 0. And for the last one, if we have g of t is equal to negative 3/2, then we would say something like g prime of t is equal to 0. So the derivative of a constant is equal to 0, the constant rule. The simple power rule is something that you probably worked a little bit with in pre-calculus, and that's a pretty easy concept where you have x to the n power, the derivative of, and then remember that that's what the dx means. It means to take the derivative of x to the n, so you get n times x to the n minus 1. So if we're going to find the derivative of each one of these functions, we're going to take, we have f prime for a, I should probably put the a on there, f prime of x then is equal to 3 times x to the 3 minus 1 power, which simplifies to 3x squared. For b, we have a little rewrite here that most of us like to do, which is equal to x to the negative 2 power. And then we'll say y prime is equal to negative 2x to the negative 2 minus 1. So remember, we're subtracting 1 from the exponent. So that gives us negative 2x to the negative 3 power. So rewriting this, we have y prime is equal to negative 2 over x cubed. And then for c we have g prime of t is simply equal to 1. Just as I have up here, the derivative of x with respect to x is just 1. So we're dealing with the same situation there. Okay. Now, find example 3, finding the slope of a graph then. So we very often, oh, by the way, I have a little note here, use negative exponents, do a simple rewrite, okay? And I've already covered that in example 2b. So example 3, find the slopes of the graph of f of x at x is equal to negative 2, negative 1, 0, 1, and 2. And so you could use your graphing calculator, or if you don't have a graphing calculator, use your phone with your 84 graph or whatever version you have on your iPad. Either would work. So just to check to see what answer you would get. Okay, so here's our graph. So the first thing that we want to do, if we're going to find this, we begin by saying, well, what is the slope of the graph? Well, we have f prime of x is equal to 2x. So then we just start plugging numbers in. So I'm going to make a column x. There's my x values, and then I'm going to make my f prime of x column, just because it'll be kind of easy to get the values anyhow. So I'm going to use the values -2, -1, 0, 1, and 2. And so if I put -2 in, I get 2 times -2, which is -4. If I put in -1, I get 2 times -1, which is -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. So you see a little bit of symmetry in here with this, right? With the line 2x, it has origin symmetry. So when you look at the graph and your graphing calculator, you can find the slope of the graph. I'm not sure I want to tell you this now, but if you use your second trace 6 and the x value, enter, and at the bottom of the window you should see the dy dx. So try that function out where you're getting the dy dx value. You have to plug in the x value, and I'll leave you to work with that. Example 4, use the power and the constant multiple rules. So for example 4, I'm just going to be doing the same thing I have been doing, but just to show you that if we have dy dx for a, if I have dy dx, it's equal to the derivative with respect to x of 2x to the 1/2 power. So I'm just going to say that this is equal to 2 times the derivative with respect to x of x to the 1/2 power, which is equal to 2. And so now I'm going to work with just the derivative part. 2 times 1/2 x to the 1/2 minus 1 power. So it simplifies to x to the 1/2, -1/2 power, sorry. Okay, so the answer for this is dy dx is equal to x to the -1/2 power. Let's get this a little smaller here. Which is then equal to 1 over the square root of x. Okay, if I have, for b, I have f prime of t. F prime of t is equal to the derivative with respect to t of 4/5, and I'm going to rewrite this a little bit, 4/5 times t squared. So I'll pull out the 4/5 as the constant, and then multiply by the derivative with respect to t of t squared. So we have f prime of t is equal to 4/5 times 2t. So just to clarify again, the derivative with respect to t of t squared is 2t. And so our answer in simplified form then is f prime of t is equal to 8/5 t. Okay, so I'm going to pause right now, and I'll pick up to finish the lesson with example 5, and I'll be right back.